3 log base 7. All right, the 49 here can be written as 7 to the power of 2. Okay, so now, okay. All right, so 7 to the power of 2. And now all this is in a 6th root, which is to the power of 1 over 6. So then 2 and 1 over 6 will be a power of 1/3, right? So here we have 3 log 7, 7 to the power of 1 over 3. Okay, what happens now? This 3 can be a power of the 7 as well. So it'll be log, or you can do it the other way. So 1 over 3 can come down and become, right, it's just 1. That's why it's so fun. So it's 1 over 3 times 3 log 7, 7. 1 over 3 times 3 is 1. Log 7, 7 is 1. So the answer is 1. Okay? All right, so in the case of the next one, each of the exponents are going to become coefficients. So 4 comes down, and it's 4 times 3 ln of e minus 2 times 2 ln of e. What's ln of e? 1. 1. So it's 12 minus 2 times 2 is 4, and it's 8. Okay? JR, more writing. Okay. Okay. All right, what we're going to do now is expand. So here we have expressions that we want to expand. When you expand, you're going to use the 3 properties again that we talked about before. Okay? So it is product property, quotient property, power property. All right, so what I have here is x squared and root e are being multiplied. I'm going to expand it. However many elements are in here, that's how many ln's I'm going to end up with. So for example, I have an x squared and I have a root e, right? I consider that 2 elements. At the end of the day, I'm going to end up with 2 ln's. Okay, 1 for the x squared, 1 for the root e. So what I get here is ln of x squared, and because there is a multiplication in between x squared and root e, I say plus ln of root e. Now, it's very, very easy because these are not extremely complex, okay, as pre-calculus honors problems go. I've seen lots and lots of times where students are just rushing through this, yeah, this is fun, I'm on a roll, and then you just miss something and it's points off. Okay, so please, when you're doing these, focus so, you just get the points that are due, right? So the 2, which is an exponent, will come down and it'll be a coefficient, plus ln of e to the what? 1/2, right? So here we have 2 ln of x plus 1/2 ln of e, which will be 2 ln of x plus 1/2. Okay? Yeah. So this is one of the basic ones, and then, they can be more complex. Level of difficulty is, pretty much the same for these. Okay, so here for question B, I have cube root of x on top, and on the bottom I have 36 and y to the 4. So basically 3 different elements means I'm going to end up with 3 different logs. The base of the log will remain consistent. So what I have here, again, go in parts. Don't try to mix steps here. Log base 6, cube root of x. Okay, now, whatever is in the denominator is being divided, meaning it all gets a negative, right? Each one of these will get a minus, okay? So it's minus log 6 of 36 minus log 6 y to the 4. Okay? You have to separate them because you're expanding. When you're expanding, the argument of the log can be one element only. You can't have a combination in an argument of a log when you're expanding. Okay? Because they're both in the denominator, there is a negative. So the way I tell my students always is whatever is in the denominator, it's like they're second-class citizens. They live downstairs, and any second-class citizen gets a minus right off the bat. Okay? So that's how I remember. Yeah. Yes, we're not done yet. Okay, so we have things to change everywhere here. So this is log base 6 x to the 1/3 minus log base 6. 36 can be written as 6 squared minus, the 4 is going to come down eventually. I'll leave it for the next step. So here the 1/3 will become a coefficient. 1/3 log 6x. What are we going to get here with the log base 6 of 6 squared? 2. And I write my constants at the very end. So I'm going to write this term first. Negative log base negative 4 log base 6 of y minus 2. Okay? Yes. The 4 is the power. Okay. I have an asterisk in front of this one, and it's on purpose because students see this and their first instinct is to distribute the ln between the 2x and the 3. But you can't do that, right? So it's ln of 2x minus 3. 2x minus 3 is it's a compartment of its own. You can't distribute the ln to it. So immediately I go in and I put a set of parentheses around it. Because they're being multiplied, not subtracted. Okay? All right, so here I have ln of 2x minus 3 minus ln of 3, right? That's downstairs. Times ln of 4th root of xyz. Okay? Now I'm fine for the first term. I'm fine for the second term. This term needs to be simplified, right? So here we have a minus. So we have ln of 2x minus 3. I'm just going to rewrite it. Minus ln of 3 minus, I have to split this up now, right? So what is ln of 4th root of xyz? And there are different ways of doing this. You might have a shorter way of doing it. That's totally fine. So this is ln of xyz to the power of 1/4, right? So let me just focus on this part. And I want to solve it off, and I want to expand it off to the side here. So I have ln of xyz to the power of 1/4. What happens to the 1/4 now? It comes down and it becomes a coefficient. So I have 1/4 ln of xyz. So this is 1/4 times what? ln of x plus ln of y plus ln of z. Does that make sense? Okay. So I'm going to substitute that back in here now. Because you're expanding, and like I said, when you're expanding, the argument should only be one separate element, right?
Can we just distribute it now?
Mm-hmm.
Should we, if we had this like on the first one, do you want us to
Distribute. No, you can leave it like this. So minus ln of 3. As far as the distribution, honestly, I am fine with whether you leave it out here or if you distribute. I know you can do that, okay? So I'm fine with either. Just make sure that the parentheses are placed properly. So it's 1/4 ln of x plus ln of y plus ln of z. You're going to have lots of, other problems on the test where there's lots and lots of little tiny calculations. Okay, so we expand, and now we're going to go in the opposite direction, and we're going to condense. When you condense a logarithm, you end up with one logarithm, and everything else is as an argument. So whereas before, when we were expanding, the exponents were becoming coefficients. Now we're going to go in the opposite direction. All right, so here the 1 over 2 is a coefficient. It becomes an exponent of the x. Square root at the end of the day. And 3 will become an exponent of this. So it's log base 4. X to the half is root x, right? So I'm just going to say root x. Now, remember what I said before about these second-class citizens? This guy has a minus, so he lives downstairs, right? So he becomes a denominator, or she, okay? Over x minus 2 cubed. Okay? No, don't. Okay, so this next one, right? Who wants to help me out with this next one?
You make it ln x plus 1 to the 5th
Mm-hmm.
plus ln x to the 6th.
Ln x to the power of 6. So it's ln x plus 1 to the 5th plus ln of x to the 6th. Then what?
There's like, this was like distributed. I don't know what the group was before.
So who can? Right, so now we're going to condense them into a single ln. So it's ln x plus 1 to the 5th. X to the 6th is it has a plus, so it's multiplied to what we had before. Yeah. No, you don't have to distribute the cubes and the 5th root, the power of 5 at all. Okay. So change of base formula. Do we remember change of base formula from last year? I'm sure you've done it before. Basically, what we can do with the change of base formula is, you've seen logarithms in different bases, right? It is possible to change the base. Like here we have a log base 6. It's possible to change it to a common logarithm. What's the base of the common logarithm? 10, right? So the formula in which to do that is, so if you have log base 6 of 4, this is one of the simplest things in this lesson. So we're going to get log of 4, okay, divided by log of this base. Yeah. Right, so remember, it is just like it's written here. Whatever is higher goes on top. Whichever one is lower goes on the bottom. Okay? And now with this, you can put it into your calculator. So it used to be, now with your new versions of the TI-84, you can input a base and an argument just as it is here, but it used to be that, you couldn't do that. So this would have been a good way for you to be able to figure that out on your calculator. All right, so if we do plug this in, log of, is everybody in agreement here?
0.774.
So it's 0.774, right? 3 decimal places, so the thousandths place. Okay? Any questions on how we did this one? Okay. So go ahead and do the next one and write it in terms of a decimal to 3 places. Write the extra 0. Right, so it's going to be, so it's log of 4,212 divided by log of 4. Okay? So where you place your parentheses matter, especially when you're dividing. So this is, okay, let me have your attention for another minute. 6.020. Now, this homework, assignment 3, will be due tomorrow. So let me just go over the timeline here. It's going to be due tomorrow. Tomorrow is Friday. We're going to go over section 4.